Hi, this is my CA1 alpha testing submission. I've developed a third person stealth game following along with a Udemy course by Gorka Games. So the game features stealth mechanics such as crouching, enemy detection, AI patrol systems, uh, guard waypoints, um, combat takedowns, interactions, various animations, crouch, dodge, roll, um, and takedowns. Um, so I just will demo my environment and discuss my testing then, and then show performance metrics and detail my play testing plan, and then explain the design patterns used. So I'll just play the game to demonstrate the core mechanics. So you just start off here. You can see the AI guard on patrol. So you can press control to crouch. He has his own perception view, field of view in front. So you just need to make sure you're behind the guard. I just have a capsule component there to detect height. This is the lever for the sensor bars. If you press E to interact, you can disable them, because if you walk into them, you'll trip the alarm. So he didn't see me. So I have to make sure I don't stay in the sensor for too long, or I'll trip the alarm. And then E for a takedown. And it triggers the ragdoll animation. But yeah, that's it. I'll just show what happens when you trip the alarms. So it can either be detected by the guard, or it can be detected by the sensor bars or the sensors. So just for example, maybe stayed in for too long. And then when you're caught, the captured widget appears. That's basically it. So now I'd like to discuss automated testing in Unreal. I have my session front end window open here, and in the automation tab I have built my own tests. So stealth game, and then I have 10 functional tests and 20 unit tests. So the functional tests are the AI patrol waypoints, alarm, architecture for the interfaces, combat takedowns, interactions with the lever, player crouch, sensors, bar detection, rotative detection, UI, detection meter, and takedown prompt. And then the unit tests, there's AI tests, capsule, height, standing, combat takedown, range, various mat tests, position tests, and UI tests. So I'll just run these tests now. This is the message log. So this is successful. You can see there's no critical errors, and 30 tests, 0 fails. So that's great. I got it working after all this time. I have just the Visual Studio window open as well, just so you can see my CPP file. So I have it written: functional tests, bar sensor detection, crouch mechanics, takedown, patrol waypoints, and it's in the Solution Explorer in my source folder. CPP, I have my build file as well. Yeah, so yeah, these tests show that the game's functions are working correctly, and they test the logic and the math and how the different systems integrate. But these tests can't tell us if the game is fun or intuitive or balanced. So that's where the play testing will come in, which I'll discuss shortly. But the test coverage, I'd say, is roughly 2/3 of the way covering the critical systems. So complex calculations that are error prone, focusing on the core gameplay mechanics that are probably more likely to break. I'd like to discuss performance and profiling. Just in my level, I'll just have it running for a couple of minutes just to show you FPS and just to see the frame rates at certain parts of the level. I'll just play it now. I just want to be out of the way a bit at the start, just so we can type in these commands. It's in the console, stat, FPS. So I'm getting 80 to 85, 11.5 milliseconds. Press tab to roll. Just press E. So the guard's going to come back around, but he won't see me. I'll type in stat unit. You can see frame latency 11 milliseconds. The GPU time 10 milliseconds, memory 6.84 gigabytes. Let's see, does anything happen? Running around, I see the frame rate fluctuate a little bit. It's the takedown. But, appears to be consistent. I'll just do one more. Stat memory. You can see 100% memory used. Pixel shader. These are low, quite low figures. Use string pool because the level's quite basic still. I don't have many assets or textures, so there doesn't appear to be many bottlenecks at the moment. Yeah, that's it for performance. I could just show maybe BP alarm. There is casting here, cast to game mode, stealth game mode, which can hurt performance. Cast to BP AI guard. So it's for the logic alert guard logic. There's cast to stealth game mode here as well. Yeah, there are potential areas for improvement for beta, but they don't seem to be harming performance at the moment. But it's just something to be mindful of. I'd like to discuss my playtesting plan. I have all the documentation submitted, but I'll just go over it a bit in the screencast. So my plan is to test the core gameplay. Is it engaging or rewarding? Does the player understand the objectives without it tutoring? Is the difficulty balanced? The game feel, responsiveness, is it responsive, intuitive? Does it feel natural? Are the takedown animations satisfying? Does the player movement feel smooth across the terrain? Then there's questions about AI clarity. Can they predict patrol patterns? Is it clear when the guards are alerted? Do they behave in believable ways? Sensor detection. Is detection feedback clear for the detection meter widget? Can players gauge when they're about to be spotted? Are sensor ranges fair and understandable? And then the visual and audio feedback. Are alarm states clearly communicated? Is the audio feedback helpful for stealth? Are the UI elements readable and helpful? Level design. Can players navigate intuitively? Are there multiple approaches, different options for stealth to complete the level? Is the layout interesting and explorable? So I'll have roughly 5 to 8 players with different gaming experience, around 5 minutes play time, and then I'll be observing the gameplay and noting any commentary. So the process will be a brief introduction with minimal instructions, basic gameplay buttons, and observe the gameplay. I said probably 5 minutes only, and then there'll be a post-play questionnaire which I have on Microsoft Forms, and then just informal discussion after. What did they like, what they didn't like, what was confusing, or what could be improved. So some metrics I could collect would be how long it took to complete, and then eventually would have a leaderboard system, number of detections, how many failed attempts, areas players got stuck or confused, or where the mechanics discovered, which mechanics players discovered versus missed. Automated testing versus play testing. So the automated testing does all the maths calculations, logic, system functionality, performance regressions, frame rate, memory, repeatability, same results. And then the play testing covers the more subjective side of it, like the emotions, the fun factor, engagement, immersion, discovery, accessibility, or unexpected elements. And then the integration with the software development would be alpha, which is the current one, automated testing, play testing, functionality over polish, beta, next, execute, play testing with real players, iterate based on feedback, automated tests, continuous testing, and then for release be final play testing and automated regression before release, performance profiling of variety of hardware. From this playtesting, I hope to learn which mechanics are most release enjoyable, where players struggle, or whether difficulty is appropriate, if it communicates systems clearly enough, what areas need tutorials or better feedback, and then just basic balance issues. Is still too hard or easy? Hopefully this feedback will inform the beta development and help to create a more polished, player-friendly final version. I'd like to discuss the design patterns in my game. So the main pattern would be the observer pattern. So allows objects to watch and react to changes in other objects without tight coupling. So when the player enters the detection range, the sensor broadcasts to the event through blueprint interfaces. The guards implementing their interface receive notifications. Each guard responds based on its own state. The alarm system and UI detection meter also observe these events, and no system needs direct references to other systems. So the benefit, new guards can be added without modifying the sensor code, and sensors broadcast without knowing which observers exist, so changes to one system don't affect the other. This makes the code easier to maintain and extend. The component pattern separates functionality into reusable components that can be attached to actors. So implementation in the game includes the capsule components for collision, movement components for locomotion, detection components for the sensors, and there's components for the waypoint system as well, attached to the BP guard. The same detection logic is reused across the sensors, spar sensors, and the guard AI, attaching the same component type with different configurations. The components can be used across different actors, and functionality can be added or removed. The state pattern allows objects to change behavior based on internal state. So the behavior tree for the AI guards has different states, so patrol, chase, catch, waypoint patrol, and then the player has standing and crouch states with different movement speeds and detection ranges. States are implemented using enumeration in blueprints. So new states can be added without breaking existing logic, and the state transitions are defined. And state-specific behavior is easy to debug. Modularity, these patterns create code through loose coupling. Systems communicate through interfaces rather than direct references, and when adding new features, existing code does not need modification. For example, adding a new sensor type requires no changes to guard AI because both use the same interface system. I just have some windows open just to give you a sense of this. This is the behavior tree for the guard. So there's different states, patrolling, idle, and then there's waypoint patrol, and then BT task, chase player, and catch. So the catch, they would have event, receive, execute AI, and then the catch and the target is the BPI guards. And for chase player, it's the same, execute AI, and then the AI move to the player character, and then there's acceptance radius, finish execute, and then run, target BPI guards. Then the BP guard has the event catch from the BPI guards, and the catch montage, animation montage, and then I just had a sphere trace there. BP robber, which is our main character. So there's the interact event, and then there's a does object implement interface BPI interact, and then object implement interface BPI guards. Target is BPI guards and BPI interact. There's the lever, has a custom event switch lever, and it's using the BPI interact event. Target is BPI interact, and then the pull lever logic. And then the sensor bar has the event interact as well. So in summary, this alpha demonstrates a functional stealth combat game environment with comprehensive automated testing using 30 tests, 10 functional tests, 20 unit tests with 100% pass rate. Good performance with no bottlenecks. We've identified optimizations for beta, and there's a structured playtesting plan in place, and the design patterns create modular maintainable code, and I've used consistent version control with clear commit messages, so I have a solid foundation for iteration in beta based on the playtesting plan, and hopefully can gather plenty of feedback in the meantime. So that's my alpha. Thank you for watching.